Hi, so let us look at the daily question from Leetcode. So, given a string integer k, we consider the word to be k special if frequency of word I minus word frequency of word j for all indices I in the string is less than equal to k, right? And we have to minimize the number of characters to delete to make the word k special. Okay, so for example, let us take one of these test cases. I'm given a word which has characters a b c d. Character A has frequency 1, B has frequency 2, I think, C has frequency 3, and D has frequency 4 or 5. 1, 2, 3, 4, 5. But in this case, A has frequency 1, D has frequency 5, so this is not case special, because for this case 2, I need the frequency of any two characters to be separated by at most 2 for this string. So I'll have to do some operations, and the operation that I'm allowed to do is that of deleting a character. So the way I can proceed with this is, first of all, I definitely need a frequency map, and then I can remove the idea of the individual characters and treat each of those frequencies as elements in an array. So for example, I get the frequency of A, and I'll just keep it in a sorted order for it, for the ease of processing. Frequency of B is 2, frequency of C is 3. It's already in sorted order in this case, right? Now the way I can process it is, I will like to make the string k special, and I'll choose one of these frequencies at a time. For example, I'll set the lower frequency threshold as the frequency, so I'll have this array to deal with now: 1 2 3 5. So lower frequency array that the lower frequency threshold that I am going to deal with now is 1, and for it to be k special, the highest frequency that it can have is 1 plus 2, which is 3. Therefore I'll have to delete all characters with frequency less than my lower frequency, and also delete all extra occurrences of characters with frequency greater than my higher frequency. So this is the idea basically over here, and in order to do it in constant time for each frequency, I can use the idea of prefix sum for this, and over here I can store the suffix sum beforehand for some higher index in this array, and for some lower index corresponding to the lower frequency in this array, and this way I'll get the number of operations that I'm required to do in order to make it case special for a given frequency. And after iterating for all the possible lower frequency thresholds, whatever gives me the minimum, that will that is something that will be my answer, and I'll return that. So I'll just quickly write on the code and then explain the code, and I think it's easy to do it. So let's start. So explaining the code so far, as I said, I'm going to iterate over all of these frequencies one by one. So for that I need a frequency map. So that is what I do over here by iterating over all the characters in the word. Now I'm only taking the non-zero frequencies and adding it to an array. And after that, because I'm going to use the prefix suffix sum and suffix sum, so first of all I'm trying to sort the array so that I take the frequencies in increasing order, and then I'm constructing a prefix sum suffix sum to do each of the operations to check for each frequency in constant time. So uh, as you can see, I'm iterating over all the frequencies one by one, starting from the smallest frequency. So the lower frequency, I'm keeping it to be the current frequency of the array, so that is, say I'm at 2, so this is the lower frequency, and the higher frequency for this case, if it is k equal to 2, then the higher frequency will be 4. Now in order to find the smallest index with frequencies greater than equal to 2, I can use lower bound. So I need to carefully use a lower bound in the array, and this gives me the smallest frequencies with value equal to the lower frequency, and by subtracting 1 I get the index of that element where I have the last element which is just smaller than the lowest frequency. And for the higher frequency index I can simply use the upper bound. Okay, so now what I do in this loop is very important. So the overall optimal answer I have initialized outside with the maximum possible value. Now, as I said, for the left operations, that is to make, I need to make all the elements lower than the lower frequency equal to 0. That is, I need to delete all those characters which have frequency less than my lowest threshold. So that will be done because I have already stored the prefix sum, and because it is one index, so I need to increase my lower index by 1 because lower index is computed on the array which is 0 indexed. Now for the right operations, so this ternary operator I have used because lower index can give me value equal to -1, and higher index if there is if the higher frequency is already greater than or equal to the highest element, then as an upper bound returns the iterator to the last to the iterator that is next to the last element, which is the array dot end. Therefore, in those cases, I'll just return 0 because I'll not require to delete any other characters. So in the other case, I need to make all the frequencies higher than the higher frequency equal to the highest frequency threshold that I have set. So for that, I can use the difference of suffix sum and the number of elements to the right into the higher frequency, and this entire term will give me the number of operations that I need to do to the right of my higher frequency. So this is the operations that is required to do to the left of the lower frequency, and this is the operation that is required to do to the right of the higher frequency. So the total operations for this lower frequency threshold, as you can take, is the sum of left operations and right operations, and then this I can keep on updating the minimum operations, and eventually I'll get the answer. And as I run this, I can see that it's getting accepted on the test cases. Let me submit it. So there it goes. So the solution is accepted. Now this required a careful disposal of the idea of the string and just dealing with the frequencies, sorting it using the idea of prefix sum, suffix sum, treating the indexes, taking the indexes very carefully, and then having a clear idea of how to use the lower bound and upper bound, because this will take the complexity and add an additional log n complexity to this solution. So the overall complexity will be n log n, which is kind of permissible because n is is around 10 to the power of 5. So this is an accepted solution, and this was the solution, my proposed solution for the daily question of Leetcode. Thank you so much.